Alright, so we've got this equation, 3 to the power of 2x minus 7 times 3 to the power of x plus 12 equals to 0. Right away, you can see that there are three terms on the left side of this equation. It's a trinomial. Also, you can see that we've got 3 to the power of x and 3 to the power of 2x. This is a typical equation that includes an exponential function and a hidden quadratic function. Our strategy is to turn this into a straight-up quadratic equation. Once we have solved that quadratic equation, then we solve the exponential equation. How we can transform this equation to a quadratic equation. Let's first tackle that 3 to the power of 2x. Remember, we have a bunch of exponent laws. Here we're going to use the product rule, which is a to the power of m times a to the power of n equals to a to the power of m times n. So this is our product rule. Product rule. We have 3 to the power of 2 times x. Going backwards, we are trying to get 3 to the power of x to the power of 2. Okay, now we can change this as 3 to the power of x to the power of 2, or 3 to the power of x squared. And then we have 7 times 3 to the power of x plus 12 equals to 0. We have actually transformed this equation to a quadratic equation. So if you don't see it, let's do it this way. Let's make it look even more like a quadratic equation. Use a little substitution. Let's say let p equals to 3 to the power of x. And 3 to the power of x squared becomes p squared. And 7 times 3 to the power of x becomes 7p plus 12 equals to 0. We've got a pure quadratic equation. You know how to solve this quadratic equation. Factoring is usually the easiest way to solve it. So you know we have those two big brackets for the factoring equals to 0. We need to find two numbers. It's going to be a p plus minus a number here times a p plus or minus a number here. So we need to find out those two numbers. So how do we find out those two numbers? The multiples of those two numbers must equal to 12. 12 is the multiple of those two numbers. Addition of those two numbers must be minus 7. So minus 7 is the addition. Be careful here. It's minus 7. You have to consider the sign in front of the number. It's minus 7. So those two numbers, we have 3 and 4. 3 times 4 is 12, but their addition is positive 7. What we need is negative 7. So what we can do is we can use negative 3 times negative 4. Then the multiple is still positive 12 and their addition is negative 7. Okay, so those two numbers are minus 3 and minus 4. All right, then we can put minus 3 and minus 4 here. So it's going to be p minus 3 times p minus 4. I've factored this quadratic equation. See, we have two solutions. First solution is p minus 3 equals to 0, which means p equals to 3. And the second solution is p minus 4 equals to 0, which means p equals to 4. Remember, we're trying to solve x, but not p. To solve for x, we also have two solutions. So, if p equals to 3, then I know 3 to the power of x equals to 3. Or if p equals to 4, then 3 to the power of x equals to 4. Now I have two exponential equations to solve for x. The first exponential equation is pretty easy. So if their base are the same, the exponents have to be the same, right? So the left side, we have 3 to the power of x. The right side, we actually have 3 to the power of 1, right? They have the same base, then their exponents must be the same. So x equals to 1. So this is one solution. Let's take a look at the second equation. So we have 3 to the power of x equals to 4. So this one is a bit different. We can't easily express 4 as 3 to some power. This is not easy. So to solve this, we need to use logarithms. One way is to change this exponential equation to its log form. Okay, we know that 3 is the base, x is the exponent, and 4 is the argument. To change it to a logarithmic form, we just need to rearrange these pieces. For a log expression, we have log base. We put base here, which is 3. Then the argument is 4 equals to the exponent, which is x. Now, x equals to log 3 of 4. Now you need your calculator to solve this. If you just hit log button on your calculator, it's assuming that you mean log base 10. If you got a logarithm with a different base, let's say log base 3 of 4, you can't just punch that button directly. What you need to do is you need to change the base of this logarithm with base of 10, which your calculator can handle. So base 3 of 4 is actually can be turned to log base of 10. I don't have to write base of 10, so I can actually remove it. Log base 10 of 4 divided by log base 10 of 3. Then your calculator can solve this. So log 4 divided by log 3 actually equals to 1.26. And this is another solution for this equation. So we have two solutions. One solution is x equals to 1, and the other solution is x equals to 1.26.